So the first 5 terms of this sequence, 14, 12, 10, 8, and 6. Title of last section of notes today is Finding a Particular Term. Formula for this section is a sub n equals a sub 1 plus in parentheses n minus 1 times d. Two new variables, a sub n will be the final term of the sequence, in this case the particular term that we're looking for. A sub 1 we did in the last section, that's the first term. N is the term number, how many total terms there are in the sequence that we're looking at. And d again from last section is the difference, how much the arithmetic sequence goes up or down. First question, we have a sub 1 equals 3, d is equal to 7, and n is equal to 14. In this case the first term is 3, the difference, or each term goes up by 7, and the number of terms in the sequence that we're looking at will be 14. We want to find the last term, find what a sub n is. A sub n is 14, so that would be a sub 14. So our final term, the 14th term, we'll find out. A sub 1 is equal to 3. N is 14 minus 1, and d from the formula would be 7. Simplifying out, 14 minus 1 would be 13. Multiplied by 7. 13 times 7 would be 91. And a sub 14 equals 94. So in this case, the 14th term of the sequence would be 94. Last question for this section. A sub 12, or the 12th term, is what we're looking for. And we'll use the sequence negative 17, negative 13, negative 9, ... as the sequence goes on forever. For this problem, again, we'll be looking for the 12th term. A sub 1 is the first term, which would be negative 17. The n in our formula is how many terms we're looking at. If we want the 12th term, n would be 12. And the difference, given the first 3 numbers, we can find out what the difference is. Negative 17 to negative 13, that increases by 4. And negative 13 to negative 9 also increases by 4. So our difference would be 4. Once we have a sub 1, n, and d, then we can plug numbers into the formula. A sub 12 would equal a sub 1, which is negative 17. N minus 1 would be 12 minus 1, and the difference would be 4. Solving out, a sub 12 equals negative 17 plus 11 times 4. So a sub 12 would be negative 17. 11 times 4 would be 44. And a sub 12 would be 27. So in this case, the 12th term of the sequence would be 27. First section of notes today is titled Find the Sum of Arithmetic Series. Two formulas for the section. S sub n, which stands for the sum of the n number of terms in the sequence, is n over 2 divided by a sub 1 plus a sub n. A second formula that we can also use to find the sum, or S sub n, would be n over 2 and in parentheses 2 times a sub 1 plus, in brackets, n minus 1 times d. So two different formulas, both find the same value, the sum of the arithmetic sequence. The difference on them, the first term uses the first formula uses the first term and last term, whereas the second formula uses the first term and then the difference. So depending on which variables you know, you can use either formula to solve the question. First question, we're going to find the sum of the numbers 1 to 100. So for the sequence, we start at 1 and counting all the numbers up to 100, we're going to find the sum or the total of all those numbers. In this case, we know the first term and we know the last term, which would be a sub 1 and a sub n, so we'll use the first formula. S sub n, and in this case it's 100 because there's 100 terms, S sub 100. N is the total number of terms. There are 100 numbers from 1 to 100, divided by 2. A sub 1 is the first number, which would be 1, and a sub n is the last number, which would be 100. So the sum, or S 100, would be 50 times 101, which would equal 5,050. So summing all the numbers from 1 to 100, it adds up to 5,050. Next question and last question for the section. Again, we will find the sum of A1, the first term, which is 5. The difference will be 1/2. And the number of terms will be 13. Looking at what we're given, a sub 1, the difference, and n, we'll be using the second formula listed. So in this case it's S sub n, and again n is 13, so this will be the sum of 13 numbers. N again would be 13, divided by 2. And again, using the second formula, it will be 2 times a sub 1, which would be 5. And add to that n minus 1, which would be 13, times the difference, which would be 1/2. Solving. 13 over 2 we can leave the same. If you want to, you can change it to a decimal. Inside parentheses, we have 2 times 5, which would be 10, plus 13 minus 1, that would be 12, and half of 12 would be 6. Solving again, we'd have 13 over 2 multiplying by 16. We can cross cancel or divide. 16 divided by 2, which would be 8, and our final answer would be 13 times 8, which would be 104. So again, starting at the first term 5, the difference is 1/2, which means every number goes up by 1/2. If we do that for 13 numbers, add all the numbers up, it would result in 104. Next section of notes is titled Finding Terms with the Sum. First question, and only question for the section, is find the first term. And the information given, D, the difference, is -4. N, the number of terms, is 42. And S sub 42, which is the sum of 42 terms, is -3,360. Using the sum, again we have two formulas that find the sum or that we can use when given the sum. In this case we have the difference is -4, so we want to use the second formula that has the difference in there. S sub 42, the sum, is -3,360 equals n over 2, n is 42, divided by 2. In parentheses, 2 times a sub 1. A sub 1 we don't know, that's what we're looking for, the first term. Plus n minus 1. N again is 42 minus 1 times the difference, which would be -4. Solving, -3,360. 42 divided by 2 would be 21. 2 times a1 would stay the same. 42 minus 1 would be 41. And multiplying 41 times -4, that would be -164. Solving from here, we can divide by 21. -3,360 divided by 21 would be -160 equals 2 times a sub 1 minus 164. Solving, we can add 164 to both sides. So 4 equals 2 times a sub 1 divided by 2, and we'll get the answer a sub 1 is equal to 2. So given the sum, given the difference, and the number of terms, we can find that the first term in the sequence would be 2. Last section of notes today is titled Sigma Notation. The definition or formula for this section: sigma is a Greek letter in the alphabet. On the bottom of the sigma, we'll have n equals x. In the question, x will be a number, so it'll tell you what n is equal to. And the top of the sigma will put a y, which will be the final number. And this is going to be equal to the sum of terms from x to y. So sigma notation stands for the sum, and we'll add the terms from the bottom, whatever x is, all the way to up to what y is, and the total of that sum will be the answer for the sigma notation. First question, we'll have sigma. N is equal to 1. The top number is 6, so we'll be summing the numbers from 1 to 6. After the sigma, we'll have an equation, which is 2n plus 11. What we'll do for this question is we'll start at n equals 1, we'll plug it into the equation and get a number. Then we'll go up to number 2 for n equals 2. Plug the 2 in, get a number. Continue for 3, 4, 5, and all the way up to 6. Add those numbers for answer. For example, if n equals 1, plugging a 1 in, we'll have 2 times 1 plus 11. 2 times 1 would be 2, plus 11 would be 13. So our first number that we're going to add to the sequence would be 13. N equals 1, going to the next number would be a 2. So we'll plug a 2 in for n. This will be 2 times 2 plus 11. This time 4 plus 11 would be 15. So our first term is 13, our second term is 15, and we'll continue on until we have 6 terms, and then we'll add all 6 terms up for our answer. N equals 3. 2 times 3 plus 11. That would be 17. 2 times 4 plus 11. That would be 19. As before with sequences, you'll start to see a pattern. 19, the next number would be 21. And that would be 2 times 5 plus 11. Again, we're continuing up to 6. So our final number would be 2 times 6 plus 11, which will be 23. Adding all these numbers up together will be the answer to the sigma notation. We're summing the numbers from 1 to 6 using the given formula. Adding those up, our total would be 108. This is one way to solve this problem. A different way to solve this problem would be to find the first term, also find the last term, and then you can use one of the summation formulas that we did with a sub 1 and a sub n. Title of the first section of notes is Find the next term in a geometric sequence. Geometric sequence is a series of numbers like a arithmetic sequence. The difference is geometric will be multiplying by a number rather than adding or subtracting a number. First sequence we'll look at is negative 120, 60, negative 30, and 15. Dot 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 means the series will continue forever and ever. Find the next term just means we want to find the next number. For a geometric sequence, we want to find what r is. R is the rate, which is the number we're multiplying by each time to get the new number. To find what r is, you can take the second number, which is 60, and divide by the first number, which is negative 120. Dividing the second by the first number tells you what r would be. In this case, it would be negative 1/2. So each number is being multiplied by negative 1/2. So for next number is 15. 15 times negative 1/2. If you put it in decimal form, that would be negative 7.5. You could also do negative 15 over 2. Next sequence and last sequence for the section is 8, 20, 50, 125, dot dot dot. To find the next number in the sequence, again, first we want to find r, which is the rate. Taking the second number, dividing by the first number, would be 20 over 8, or changing to a decimal would be 2.5. So each number is being multiplied by 2.5. So our next term would be 125 times 2.5, which would be 312.5. Title of the next section is Finding an indicated term of a geometric sequence. The formula for a geometric sequence is a sub n, which again is the final term, times a sub 1, which is the first term, times r, which in the previous problems the rate, the number you're multiplying by each time, to the exponent of n minus 1. N again is the number of terms in the sequence. First question, we want to find the 8th term. When a sub 1 equals negative 3 and r equals negative 2. Using the formula, a sub n, if we're looking for the 8th term, would be a sub 8. A sub 1, the first term, is negative 3. And we're multiplying by r, which is negative 2, to the exponent of n minus 1, which would be 8 minus 1. So a sub 8, or the 8th term. Negative 3 would stay the same. We'll do exponents first before we multiply. 8 minus 1 would be 7, and negative 2 to the 7th power would be negative 128. Multiplying that out, the 8th term comes out to 384. Negative 3 times negative 128. So again, what this means is you start at the first term, negative 3. We're multiplying by negative 2 each time. The 8th term would be 384. Next problem, which is the last problem for the section. We want to find a sub n for the sequence 1/5, 1, 5, ... Again, we'll use the same formula, same numbers. A sub 1, the first term is given, is 1/5. And we want to find out what r is equal to. R again, you can take the second number and divide by the first number. In this case, it would be 1 divided by 1/5. Instead of dividing by 1/5, we can multiply by the reciprocal. So r would just be equal to 5. Finding a sub 9. A sub 1 is 1/5 times r, which is 5, to the exponent of n minus 1. The 9 means there's 9 terms, so 9 minus 1. One-fifth would stay the same. 9 minus 1 would be 8, so we have 5 to the 8th power. That number comes out to be 390,625. We're still multiplying that number by 1/5 or dividing by 5, so our final answer would be 78,125. Again, starting with the sequence 1/5, 1, 5, multiplying by 5 each time, the ninth number would be 78,125. Next section of notes is titled Write an equation given a sequence. First sequence we have is 36, 12, 4, ... Given this sequence, we can write a formula. The formula will include the first term and also the rate. The first term again is just the first number, which is 36. And the rate, again, take the second number divided by the first number, 12 over 36, which reduces to 1/3. To write an equation, we'll use the same equation from the previous section. A sub n equals a sub 1 times r to the n minus 1 power. For the equations, a sub n would stay the same. A sub 1 would be 36. The rate would be 1/3. And n minus 1, the exponent, would stay the same. We can put parentheses around the rate just to keep that separated. So our equation would be 36 times 1/3 to the exponent n minus 1. Next sequence we'll look at is -2, 10, -50, ... Again, the two numbers we need are a sub 1 and also the rate. A sub 1's just the first number, which would be -2, and the rate is the second number divided by the first number, which will be -5. And our equation again would be an, or a sub n, equals the first term, a sub 1, times the rate, which would be -5, and the exponent is always n minus 1 for geometric sequences. Title of the last section of notes is Geometric Mean. The definition of geometric mean is the missing terms of a sequence. First sequence we'll look at is 9, and then a blank spot, which we'll find a number for, followed by 2 more blank spots. And the last number would be 144. In this case, the first number of the sequence is 9. We want to find the